Hello again and welcome to the MathTablet. In this session we're having a look at the gradient between 2 points. Okay. Now we tend to use a formula. Little m is usually reserved for finding the gradient. Okay. And with this formula it is distance between your y coordinates over distance between your x coordinates. Let me just fix that up. Okay, so basically this is a version of rise over run. Right, let's have a look at how this formula works. Suppose I have the point 6, -3 and another point -7, 0. Okay, so let's have a look at what that might look like on the Cartesian plane. So 6, -3 would be about here somewhere, and -7, 0 will probably be way over here somewhere. Okay, now this is a graph by no means, it's really just a sketch. My point here is just to get an idea of whether you expect the gradient to be a positive one or a negative one. Okay, so because of the positioning of these 2 points here, we are expecting the line joining those 2 points to have a gradient that is negative, because going from left to right, the line is sloping downward, so we would expect a negative value for the gradient. So let's just double check that with the formula as well. So as per usual, we'll call that one x1, y1, call that one x2, y2. So putting it into the formula now, so m would be equal to y2, which is 0, minus y1, so it's going to be 0 minus -3 in this case. And then in the denominator we've got x2 minus x1, so it's going to be -7 take 6, which means my gradient is going to be 3 over -13. Right, or if you prefer -3 over 13. Either way, you can tell that your gradient here is a negative value, which is consistent with what we were saying with our quick sketch. Now, just to give you an idea of the formula itself, okay, so if we've got any 2 points on that Cartesian plane, right, so let's say that one there, x1, y1, and that point there, x2, y2. And the line joining them in this case would look like that. Okay, I said a little while ago that the formula is a version of the rise over run. I just wanted to show you where that formula comes from. This distance would be the run, wouldn't it? Okay, so we'll call that the run, and that distance there would be the rise. If we were to work out the gradient, basically you would be wanting to divide the rise by the run to get an idea of how steep that line is. Now, because of the positioning of the points there, this value will be x1 and that value will be y1, and over here we've got x2 and y2. Okay, so let's have a think about that run part. That distance must be given by this value, subtract this value. So the run there is very much x2 minus x1, as in the distance between those two x coordinates. And this distance on the other side of the triangle, the rise, is basically the distance between your y coordinates. Okay, so that's going to be the y2 minus y1. Now, putting that into the general form for the gradient, instead of the rise we'd have y2 minus y1, and instead of the run we've got x2 minus x1. Alright, so that's basically a more complicated looking version compared to rise over run, but the idea is still the same. And we use that formula whenever we've got 2 points on the Cartesian plane and we're trying to find the gradient of the line between those 2 points. Thank you for listening in to the Math Tablet.